So yesterday we were talking about going from a point or finding a certain theta angle, okay, and then finding other points that have the exact same values, the exact same trig values from that point. Okay? And we found that by we go a full another lap around in either direction. So the example that I used yesterday and the examples that I'll use again today is pi over 3. Okay? So if I go to pi over 3, my cosine value is 1/2. My sine value is is square root of 3 over 2. My tangent value is the square root of 3. My secant value is 2. My cosecant value is 2 over the square root of 3. And my cotangent value is 1 over the square root of 3. Okay? So I get that all from pi over 3. If I go around the circle 2 pi more radians, or I go around the circle 2 pi less radians, as long as I make a complete circle, a complete full 2 pi lap, I'm back at the exact same spot, and those 6 values are all exactly the same. So those 6 values would hold at 7 pi over 3. Those 6 values would hold at 13 pi over 3. Those 6 values would hold at negative 5 pi over 3. Those 6 values would hold at negative 11 pi over 3. Okay? And so on and so forth. Everybody good with that? Okay? Now, let's tweak it a little bit. Instead of going a full circle, 2 pi, let's go pi. So what part of the circle is that? I'm only going pi around. Half the circle. So I'm only going halfway around. So again, we'll start at pi over 3, and I don't care which direction you go. Side note, you probably want out your unit circle so that you don't have to keep straining yourselves looking up here. Okay? And in a little bit, we'll do a 2-finger type thing. Okay? All right? So I go halfway around the circle, and I don't care which direction I go in, but if I go halfway around the circle, where am I at? 4 pi over 3. So I end up at 4 pi over 3. So if I'm talking about the cosine of pi over 3, that's going to be 1/2. If I'm talking about the cosine of pi over 3 plus or minus pi, halfway around the circle, then I'm talking about that I'm at the cosine of 4 pi over 3, which, what is the value then of the cosine of 4 pi over 3? Value of cosine at 4 pi over 3. Negative 1/2. Okay? So that's negative 1/2. Clear up. I can move my stuff if you want to come to the table. Okay. Okay. Agree? Do we see a relationship possibly building or a pattern developing between those two? You may want to step out on a limb and tell me what pattern they see. They're opposites, right? So what we're tentatively seeing is we're seeing that this would be the negative cosine of t. Agree? But just wait, don't write it down yet. That's what we're tentatively seeing. Let's see if it works out. Okay? So, you all have 10 fingers, hopefully. If you don't, I'm sorry for your loss. Okay? I need 2 of them. I need your 2 index fingers. Okay? And what you're going to do is you're going to start at, so I'm going to start on your unit circle so that you follow along. I'm going to start at pi over 3, and 4 pi over 3 because that's the one that we just did. Okay? And those cosine values, so I'm looking at the x part of those points. Okay? So put your left finger, or put one finger on one and one finger on the other. Okay? And those cosine values are opposites. Yes? Okay? Now, which way you go around the circle, I don't care, but both fingers have to move in the same direction. Okay? So I'm going to go clockwise, or excuse me, counterclockwise. So I go to here. Are those cosine values opposite of one another? Are they? They're the same. Let's try, let's go one more and let's just see. Opposites. Yes, opposites. Yes, opposites. Yep, opposites. Yep, opposites. Yep, opposites. Yep, and then I'm back to where I started, right? So what about this 0? 0 and 0. Are those opposites? Are they? Okay, so -1 times 0 is just still 0, right? So technically they are opposites. So yes, now we can write it down. We just went all the way around the circle and we proved that the cosine halfway around the circle is the opposite of the cosine of where I'm at. Okay? Now let's look at sine. The sine at pi over 3 is equal to the square root of 3 over 2. Halfway around the circle, it's going to equal what? What's the sine at 4 pi over 3? So negative square root 3 over 2? Agree? So tentatively we're thinking opposite of the sine of t. Yes? Two finger it. Go around the circle and verify. Make sure that that works out. If you go all the way around the circle, is sines always opposite? Yes? The only one where it's not is going to be now at 0 and pi, right? Because that's where sine is there. That's where y is 0. And again, same logic holds. So that works out. Okay? Now, tangent. What about tangent? What about tangent? Well, doing some maths, the tangent of t plus or minus pi is going to be equal to the sine of t plus or minus pi divided by the cosine of t plus or minus pi. Agree with that statement? Tangent is sine divided by cosine. Okay? Well, we just said that the sine of t plus or minus pi was equal to the negative sine of t. Right? And we just said that the cosine of t plus or minus pi was negative cosine of t. Right? Negative divided by a negative is a positive. So this ends up being the sine of t divided by the cosine of t. And what's sine divided by cosine? Tangent. So this equals the tangent of t. So this is the tangent of t. And no need to two-finger that one because we mathematically proved it. Now, side note on your unit circle. Side note on your unit circle. If you notice up here in quadrant number 1, there's extra numbers on the outside of the coordinates of the point. Do you know what those extra numbers are? That's the tangent value at those angles. Okay? Those are the tangent values for you at those angles. Side note for you on that. Okay? Good to go on that one. Love it. Excited. Let's go on. Okay? Now, opposite values. So, whoops, I forgot. I need a shade. I need, we'll go down here, and we'll go down here, and we'll shade that like that. Okay? Alright? So, if I start out, and I'm going to use my pi over 3 again, my go-to angle. If I have a t value equal to pi over 3, I would go all the way up to there, right? Well, that would put me at the point 1/2, comma, square root 3 over 2. That would give me a sine value of, a cosine value of 1/2. A sine value of positive root 3 over 2. A tangent value of the square root of 3. A secant value of 2. A cosecant value of 2 over the square root of 3. And a cotangent value of 1 over the square root of 3. Okay? Again, got it memorized. Okay? Just because that's my go-to point. Okay? With me? Now, what this section is saying is if I go in the opposite direction. So instead of going up in the positive direction, now I'm going to go down in the negative direction. I'm going the opposite value. Okay? So that means instead of me going up here to positive pi over 3, okay, I'm going to go in a negative pi over 3 range, which is going to put me at I should go in green now. The cosine of negative pi over 3 is going to be really the value of the cosine of 5 pi over 3, which is going to be what? What's the value of the cosine at 5 pi over 3? 1/2. So tentatively we're looking at, they're the same, right? Agree? Okay. Now, let's look at a t value greater than pi. Okay? So I'm going to go with 5 pi over 4. So my t value is 5 pi over 4, which means that I would go all the way around in the positive direction to 5 pi over 4. Right? So I'm down here. Okay? If I go in the negative direction, here, let me put this up here on this one. So I would go from here, I would go all the way around to 5 pi over 4. If I go a t-value negatively 5 pi over 4, that's going to have me go down here, all the way around to here. Cosinely, or x-valuely, if you will, are they the same? Do they line up vertically? Yep, they line up vertically, so that would hold. Okay, so that's my rule. Okay. Now, let's talk sines. What's the sine value at pi over 3? Well, it's the square root of 3 over 2, right? What's the sine value at negative pi over 3, or the sine value at 5 pi over 3? It's opposite. So it's negative square root 3 over 2. Agree? So tentatively speaking, we're saying that this is going to be negative sine of t. Let's use 5 pi over 4. If I go to 5 pi over 4, what's the sine at 5 pi over 4? Negative at 5 pi over 4?
Oh, whoops. Negative square root 2.
Negative root 2 over 2. At what's the sine of negative 5 pi over 4? Which really is 3 pi over 4. Learn? Square root 2 over 2. Are those still opposites? Yep. Yep. And that is the rule for those things. Okay? Mathematically speaking, oops, I got to get rid of my shade now so that I can go down here. And then I can go down here and I can do some maths. Okay? Mathematically speaking, the tangent of negative t is equal to, oops, the tangent of negative t is equal to the sine of negative t over the cosine of negative t. We found right here above us that the sine of negative t is equal to the negative sine of t, and that the cosine of negative t is the cosine of t. With fractions, we can put that negative sign on top, we can put it on the bottom, or we can put it out in front, right? If I put that negative sign out in front, I get negative of the sine of t times the cosine of t. Well, sine divided by cosine is tangent, so this is negative tangent of t. So then this one would be negative tangent of t. Using your unit circle, please find me the cosine of negative 5 pi over 6 and the sine of negative 5 pi over 4. I'll give you 45 seconds. So the cosine at negative 5 pi over 6 is going to equal the cosine at 5 pi over 6, which is going to be negative root 3 over 2. The sine at negative 5 pi over 4 is going to equal negative of the sine at 5 pi over 4, which is going to be negative of, at 5 pi over 4, that's negative root 2 over 2. So that is going to end up being positive root 2 over 2. Agree with both of those? Speak now, or forever hold your peace. Good. Moving on. And, whoops. That one's the one that you guys got. Okay. So, bottom of page now. Okay. Last obviosity of the day, of the week. Then we got a unit circle memorization quiz that we're going to take yet today. Okay. Ready to go? I'm teasing. We're not taking it until next week. Brooke was ready to stab me in the throat. Okay? Alright? So, the cosine of t is equal to negative 5 over 13. Is that one of our unit circle angles? No, it's not. But is it on the unit circle? We are saying that it is on the unit circle. Okay? So we're saying that it is that this t is on the unit circle and has this value. Okay? So my first question is, which quadrants could t be located in? Which two quadrants is t negative in? Or excuse me, is the cosine of t negative in? 2 and 3. Do we agree that cosine is negative in quadrants 2 and 3? Okay? So t is located somewhere on the left side of my unit circle. Agree? Okay. Now, we had just learned on your page, right above you, that the cosine of negative t is equal to the what? What's the cosine of negative t equal to? Just regular straight up cosine of t, right? Okay. Middle of the page one says cosine of t. So the cosine of negative t is equal to what in numeric value for this particular case? What's it equal to in numeric value? Negative 5 over 13. Because that's what cosine of t is, given to me in the problem. Cosine of t minus pi. Well, we just learned that the cosine of t plus or minus pi was equal to what? Negative cosine of t. Here I'm subtracting pi. That would fall into this category. That's a bad plus. OCD's kicking in. We won't even go into the fact that it's off kilter. Okay, we will go into the fact that it's off kilter. So the cosine here of t minus pi is going to be equal to what numerically? So what's numerically?
Oh, numerically, sorry.
Numerically. What? 5 over 13. asking me to find the sine of t. How am I going to find the sine of t? What tool do I have in my toolbox to find the sine of t? What's the tool that should be in everybody's toolbox? A hammer should be in everybody's toolbox, right? What's the hammer? Missing a lot of stuff. It's on your page.
Yep. That was close. That's good. I said sine squared t.
And then you had equals.
I said equals.
Yeah.
Oops.
Yeah. I'm pretty sure we only use one equal sign in our equations, but okay.
Subtract it over, but
so what is cosine of t? What was cosine of t? Negative 5/13 plus sine squared of t equals 1. Negative 5/13 squared. Negative 5/13 squared. Negative 5 squared. 25. 13 squared. 169 plus sine squared of t. Now, instead of writing 1, what should I write to make my life easier? Even easier. 169 over 169. Now what? Subtract 25 over 169. Okay, so sine squared of t is going to equal what? Yeah? 144 over 169. Right? Now what? Square root both sides. Left side. Sine of t. Right side. 12 over 13 would only give me the coordinate in quadrant number 2. We said we had to be in quadrant number 2 and quadrant number 3. Or I should say. What was that? Plus or minus. Another way of thinking of it, I've square rooted and I'm solving. I got to add a plus or minus. Okay? So it would be positive, the sine value would be positive 12 over 13 if I was in quadrant number 2. The sine value would be negative 12 over 13 if I was in quadrant number 3. Okay? Seems like a great place to stop. Refresher, you don't have a video to watch over the weekend. However, your memorization quiz will be on your 4-mod class day.